As was mentioned earlier, 3D pre-flight planning is excellent for identifying potential emergency landing sites near the arrival procedure. There's even a built-in ruler to measure the suitability of an emergency landing field. We can measure the proximity of several emergency sites, including their proximity to the approach path. We can also measure the dimensions of the selected sites for suitability as well as their ground elevation. Using the zoom feature, we can look for ground obstacles or obstructions, such as fences, ditches, power line structures, etc., that may preclude a site and encourage looking for an alternative, safer location. These features can also serve the same function by surveying emergency landing sites for departures. At this point in the pre-flight planning stage, we have reviewed our weather forecast and determined the forecasted winds for our arrival will favor ZPH runway 23. Now we can plan our arrival based on the expected conditions and make observations along the approach path to enhance safety. Now let's take a look at surveying potential emergency landing sites along the approach path to see how our enhanced 3D features work to help us safely identify these sites. One consideration during planning is to determine the target altitude for arriving at the Visual 3 approach fix waypoint. As we know, altitude is our friend in most emergencies. We can generally select an arrival altitude that is 1,000 feet above the traffic pattern altitude at the V3AF waypoint, which will allow us to descend for 2 minutes at a controlled descent rate of 500 feet per minute at 90 knots ground speed to arrive at the midfield entry waypoint at traffic pattern altitude. We only need to focus on the V3AF waypoint to the MFE waypoint, since our procedures are designed to glide to the runway if at the midfield entry waypoint at traffic pattern altitude. Since we are 1,000 feet above traffic pattern altitude at the V3AF waypoint and starting our controlled descent using our conservative 8:1 glide ratio maximizes the margin of safety by allowing us to glide greater distances to a potential emergency location along the approach path if necessary. Arriving at the V3AF waypoint at 1,000 feet above traffic pattern altitude will allow for a safe, stabilized approach. Since the rate of descent is known, 500 feet per minute, we can predict our approximate altitude anywhere along the V3AF waypoint to MFE waypoint leg and use the circle function of the Google Earth Pro ruler to show us potential emergency landing sites that we can safely glide to. Using our conservative 8:1 glide ratio, we multiply our anticipated altitude times 8 and extend the circle from the flight path out to our calculated value. Now we can find the sites that are within gliding distance. The traffic pattern altitude is 1,090 feet MSL. The altitude at the V3AF waypoint would be 2,090 feet MSL. Setting the glide circle radius to 16,720 feet, which is 2,090 feet MSL times 8, the glide ratio, enables us to look for potential emergency landing sites within the circle. Let's take a look at how to enable and use the circle function of Google Earth and actually measure the 16,720 feet radius. Immediately above the image are the toolbar buttons. First, find and left-click on the ruler icon button. Second, left-click on the circle tab in the ruler window. Third, left-click on the down arrowhead of the radius drop-down box and left-click on feet. Fourth, center the mouse, the white square cursor, over the V3AF waypoint and left-click to set the center of the circle. Fifth, drag the cursor in any direction to increment the feet measurement in the ruler window to approximately 16,720 feet. The maximum glide distance has now been established based on altitude and a no-wind condition. Progressing along the approach path, the glide distance will decrease proportionally to altitude. Halfway along the path, at a 500 feet per minute descent rate, the altitude would be 1,590 feet MSL times 8 for the 8-to-1 glide ratio, which equates to 12,720 feet gliding distance. Redrawing the circle at the halfway point will identify additional emergency landing sites. Once a potential site is selected within the circle, using the zoom feature, we can look for ground obstacles or obstructions such as fences, ditches, power line structures, etc., that may preclude a site and encourage us to look for an alternative, safer location. To accomplish this, simply move the cursor over the selected field and zoom in and pan to survey the field for suitability. Using the line ruler in Google Earth, we can measure the dimensions of the site to determine its length, width, and ground elevation. Once again, find the same ruler icon in the toolbar button section above the image. First, left-click on the ruler. Second, left-click the Line tab in the ruler window to enable linear measurements. Third, select Feet from the Map Length drop-down box. Fourth, move the cursor to the touchdown spot and left-click to start a measurement. Fifth, move the mouse to measure the length of the site that will be shown in the map length row of the ruler window. Measure the width using the same technique. There is a print icon in the toolbar button section for printing hard copies of selected sites. To encourage departure emergency planning, our 3D planning features provide the ability to look for potential emergency landing sites on departures, very similar to arrival planning, providing an additional level of safety and confidence attributed to thorough, advanced 3D pre-flight planning. The same methods and techniques can be used on the en route phase of flight to calculate and generate maximum gliding distance views. Continuing the approach to the arrival airport using the zoom and pan features enables identifying points of interests on the ground, such as nav aids, taxiways, tie-down ramps, fuel islands, FBOs, windsocks, airport access roads, restaurants, lodging, approach lighting, systems, etc. A hovering information icon associated with the arrival procedure contains the procedure runway number and a 180-degree clockwise wind range for the selected runway. We have integrated our procedures with other planning sites for a one-stop shop experience. Left-clicking on this icon will open direct access to their websites, including the FAA National Flight Data Center Airport Database, Airport Facilities Directory, Lockheed Martin's Pilot Portal for legal weather briefs and flight plan filing capabilities, links to SkyVector for airspace considerations with our procedures overlaid on their charts. Additional links will be added in the future. This truly is a major advancement in pre-flight planning and opens one's imagination for enhancing the pre-flight planning process.